Hello, my dear friends. This is your Tinkering Srinivas. So, you know that I always like tinkering right from my school days. Okay. So, this is a variable voltage source. I mean, whenever I make some design, I used to test right from 170 to 270 volts AC. But however, you all know that our incoming voltage used to be in between around 220 to 230, somewhere like that. But there will be a lot of fluctuations as well. That's why we have designed voltage stabilizers earlier, almost in the year 1993 and all. So, but what happened to test the stabilizers, we need to create the voltage variation right from 170 to 270. So, for that, we have to use auto transformer. This is auto transformer. You can see this auto transformer. So, this will keep adjusting the voltage, whatever voltage you want. Okay, we call them as a Variac also. Okay, so DimmerStat. Some people also call it as a DimmerStat. So it's basically an auto transformer. You can continuously change the voltage. So you can give input to 230 volts, and you can get voltage right from 170 to 270. It will have little 35 volts up also. Step up also, and step down you can always have. So that is continuous. You can change it like that wherever you want. There are number of turns. Based on the number of turns, you see the way I'm moving the lever armature onto that particular various steps. So wherever I keep the lever, that's where whatever voltage on that particular number of turn, so that will come out. Okay, this is what is tinkered by me in the year 1993. So I need to know how much, what's the output voltage I have selected, what is the input voltage coming in, the AC voltage I mean, okay, alternating current. So I have used a switch here to know the input voltage and also output voltage. Okay, so whenever I keep it into one direction, so it will read my DPM, digital panel meter, DPM. So this will read the input AC voltage, and however, when I wanted to see what is the set voltage by this, so I can select the switch into the other direction. So this particular connections I made, I can say it this way. So this is a kind of tinkering I used to do, lot of tinkering right from my school days. I'm doing lot of tinkering. So today, the new tinker has come, Kalyan. He is a good tinker actually. So he follows me a lot. So these days he is coming to me whenever he gets some holiday and all. So he always wanted to find out some my old legacy stuff, and then he wanted to open them and see. So today he has taken this particular gadget, whether it will work again back on or not. If not, then how can we make it work? That and all. So he wanted to change the voltages and see the performance of various electrical appliances. So he has taken this concept for today. So in fact, the reason I'm explaining you this today about this video, to make you understand the kind of workmanship, the kind of logics I have applied on that day at the time, using selecting a component, and then connecting them, integrating them, and using in a cabinet like this. I especially made one wood cabinet, you see. So at that time, my company's name is PowerSense. So we used to make a lot of products. So these are the first generation my designs. Okay. So today it's really one way I'm a bit emotional also, because this is one of my test equipment of my teenage time. Okay. So I really enjoyed tinkering a lot. And I think maybe because of my tinkering abilities, so I have taken as a responsibility to be associated with Atal Innovation Mission as a regional mentor of change for especially tinkering and innovation. So we always say, innovation is the future, and the future is looking for innovators. So how do we produce such kind of tinkers and such kind of innovators and inventors and whatnot, designers and integrators, all the stuff. So one way I'm trying to establish the STEM education by reading the regular school syllabus books of CBSE and Cambridge, all that. At the same time, I'm connecting all such science concepts into STEM education. That's where my children can excel and become entrepreneurs. My ultimate goal is to mentor India in the direction of preparing them productive India through entrepreneurship. So this is what is my commitment, and this is what is my challenge too. So let me, you know, so this is almost 35 years ago. Another my assembly of DPM. So a lot of tinkering. You can see that. Okay, but today, after 35 years, when I opened it up and saw this, so I myself not able to, control myself because the kind of work I did during my teenage. So this can be a good message to all of my young generations. So maybe children at schools these days, they have all the availability of the information and the tinkering and all that you can develop with all the tools, and we can do lot much. Anyway, let's do more tinkering. Happy tinkering, keep innovating. Hello, my dear students. Though it look like big wave connections, so we have given 230 volts to the transformer, and the step down we have taken 09 to our DPM. This is historic DPM. Okay, so after very long time, after nearly 35 years, I have powered this back. Though, the connections look like vague connections. We have just connected to see our historic DPM, which we brought it around, which we made it almost, it is 1993. My God, it is almost 31 years ago. But you see now, my incoming AC voltage, it is showing me around 257, very high voltage. Okay, see. So what we have done, very simple. The 230 volts, the white cable connected primary of the transformer as well as sends to our DPM, and secondary of the transformer connected to power my DPM circuitry. Okay, you understood? So this is how now we are sensing, we are measuring the AC voltage coming to my home. You understood? So this is how my historic legacy DPM started working after 31 years. Thank you for watching this. I can connect it to the power source and then I'll show you how it works. Okay? So I hope you appreciate my tinkering. Happy tinkering. Keep innovating. You see? So a little wiring inside. Okay? And you see the lever inside the Variac. So the way I'm turning it from the knob, from the outside, inside, see, this is moving like this. And so whatever voltage, AC voltage, the 230, 240 volts, whatever, you give it to the phase input of this Variac. But output, you can get it whatever voltage you want, from 0 to the input voltage of 230, 240, whatever is available. But you can reduce to whatever level you want. Okay, that's how you can check. Okay, so I'll just close the wiring and then fix it back, and then I'll show you the outputs. Okay, then happy tinkering, keep innovating. Hello, my dear tinkers. So this is your Tinkering Srinivas on the 2nd September 2024. You see, I have totally removed the previous wiring and serviced the Variac and the DPMs inside, and finally I made it work. So firstly, this was designed and made me in the year 1993, and exactly after 30 years, you see, it is back on. So for next 30 years also it will work. Okay, so I have provided one power output socket here so that you can make use of it for the adjusted output AC voltage. And also you see here, whatever voltage you are adjusting, Okay, from here this 0 to, okay, to whatever voltage you want. So nicely you can adjust to the full voltage. That and all you will be able to see here. Okay. Okay, my dear students, now I have powered my dimmer. See, now I have connected one LED lamp onto my dimmer. I am slowly adjusting voltage. You see that my LED lamp started glowing from around 110 volts, and the brightness of that is going at 170, 180, and you see how the voltage is I am adjusting. Okay, see, it is 210 and 220, and then maximum I have given is now 255, the incoming voltage at my home. Okay, I'm reducing to 220, and then you see I'm adjusting to whatever level I want. You see 120 volts, like USA 110 volts. I can have that 110 volts also. You see 110 volts, and I can further reduce, you see, around at 80 volts. And now you see the brightness of the LED, it is still glowing, but 80 volts, because it is designed for 230 volts. Okay, see, now it stopped at 70 volts, less than 75 volts, it's not at all glowing. So it started glowing, and then you see when at 70 volts, when it is stop glowing, but it doesn't mean that it's not pulling current, it is pulling current. Okay, but only the thing, you won't see the light rays coming out, but still the circuit is closed. Okay, so I can make it to 0 also, so around 1 volt. See, every turn inside the Variac, how nicely you can adjust. It's interesting, no? So PowerSense is my company, established in the year 1993. Okay, my dear friends, all the best, take care, happy tinkering, keep innovating. So after 30 years, my legacy again started functioning. Okay, all the best, take care. Okay, let's tinker many things like this. Let's test them, the legacy equipments, and then make them work and reintegrate, redesign, remake, reinnovate, reuse, and let's make use, not just simply throwing them. Okay, let's make use of all our legacy stuff so that we can innovate. Let's innovate India towards productive India. Jai Hind, Jai Bharat, Jai Jai Vignan, happy tinkering, keep innovating. Bye-bye, signing off your science friend Srinivas from scientificstudents.com/tinker-masters.html. Bye-bye.